Okay, hi guys. So from the previous lecture, we'll be continuing on seeing more on rate law. So suppose if the concentration of each reactant was 1 m, then we can write that R equals to K, which is R equals to rate constant, and the unit of K would be unit of ROR upon molar concentration. Okay, which is nothing but unit of ROR would be mole liter inverse second inverse divided by molar concentration would be mole liter inverse to the power n. So unit of K would be written as mole 1 minus n liter n minus 1 second inverse. I hope you remember that R, or rather small r, which is the rate of reaction, would be equals to K times, or rate constant times concentration of reactants to the power n or x. Okay, so now when R is 1, K would be equals to R. Now for zero order reaction, we can write that K is equals to mole liter inverse second inverse. Why? Because n would be equals to 0, which would be same as the unit of rate of reaction. For first order, we can write that K would be equals to, as n would be equals to 1, the value of the unit of K would be second inverse. Okay, and for second order reaction, we can write that n would be equals to 1, rather n would be equals to 2, so unit of K would be mole raised to power minus 1 liter second inverse. Okay, now let's see elementary reactions. So elementary reactions are the reaction that takes place in only one step. Okay, and the reactant molecules collide with each other and directly convert into products, and no intermolecular, or rather no intermediate formation is there in elementary reaction. No intermediate formation, and reactants collide with each other to directly form products. Okay, and now let's see what's a complex reaction. So complex reaction is a reaction that takes place in more than one step. In more than one step. And second, we have that intermediate products formed, or rather intermediate products are formed in complex reactions. Intermediate products are formed in complex reactions. Okay, so now for an example, if we write that A moles of A react with B moles of B to form C moles of C, then rate law would be that the rate of reaction would be equals to rate constant times concentration of A raised to the power B and concentration of A raised to the power X and concentration of B raised to the power Y. And law of mass action says that rate would be equals to rate constant times concentration of reactant A raised to power stoichiometric coefficient of A multiplied by concentration of B raised to the power stoichiometric coefficient of B, which is small b. So for elementary reactions in which direct conversion of reactants into products take place, we can write that X is equals to A and Y equals to B, and overall rate, which is total order, would be equals to X plus B equals to A plus B. Okay. Or partial order, which is X and Y, partial order of reactants is equals to stoichiometric coefficient of reactants. So this is for elementary reactions. And for complex reaction, we will have X plus Y may or may not be equals to A plus B. A plus B. Okay. And we can also write that law of mass action is valid for elementary reaction. It has no significance for complex reactions. Mass action is valid for elementary reactions. And it is not valid for, rather not significant for complex reactions. Okay. So next we will be seeing order of reaction, which is n equals to x plus y, in the next lecture. So till then, good luck and goodbye.